Yeah, thank you very much. I would like to begin with the strategy of the wind energy regarding to the district heating system. What you see here is the future of district heating system in Vienna. Currently, we are producing about 6 terawatt hours per year for the district heating system. The figure shows you the mixture of the production in 2040. That means, on one hand, we will expanding the district heating system. That results in a higher demand of district heating system of about more than 8 terawatt hours per year. But what you see here is two bulks. One is the blue one, is the heat pump. That means large heat pump using waste heat from any kind of sources and utilize the heat for the district heating system. The next part, the geothermal part, goes to the deep geothermal energy, and that is the mixture of the future energy production in Vienna. Currently, what we have done for the plant, we already installed in the last years more than 120 megawatt large heat pumps from different kind of sources, from wastewater, from CHP plant, river water, and so on. And currently, we are also finished 3 wells for deep geothermal energy to a deepness of more than 3,500 meters. And that means we are going the way. We are going to the more renewable energy sources. And in this kind, the storage would be a topic for us. If we have deep geothermal energy in our portfolio, if we have waste heat with using our large heat pumps, and that is the reason why we are going to the topic storage systems. Good. As an operator, we have different kind of technologies for our aims. One is the short-term thermal storage with a volume of up to 55 cubic meters. There are only flexible items in the portfolio. On the right-hand side is the aquifer, that is more or less seasonal energy storage. That is seasonality. We have in Austria, in Vienna, the problem or the topic that the UTES is only available at the deepness of about 1,000 meters, and that results in a difficult economic case. And in the middle, we have the peak thermal energy storage. We are thinking here about storage volume up to 500,000 cubic meters. But the problem of such tanks in the underground is the surface. We need a solution where we can use the surface for the storage volume up to 500,000 cubic meters. And that was the reason why we said, okay, that is an interesting technology for us. How we can get to the bigger solution? We need a pilot. We need a pilot to understand the technology, to have a feeling about the cost, to have a feeling about the efficiency of the project, of such solutions. And so we came up with the project Scale Up. Okay, what is the project Scale Up? The project Scale Up has a volume of 40,000 cubic meters. It has a deepness of about 30 meters, and we are now planning a thermal capacity of 20 megawatt. And as I told you, one of the major aspects is to using the surface for other purposes, for energy usage, for people who can go on it and play football and something like that. That is one of the major aspects of the project. Of course, we want to know, okay, how would be the efficiency of the storage, and that is the reason why we are currently planning the project as a pilot project. Okay, how was the way? The way was really not so easy, but it's really an interesting way. Before 2021, we had in Austria a large project regarding to the underground storages. We get from the project some information how can we realize such a project, and we take the results of the gigatest, that was the project, and use it for a surface or for a site in Vienna. And in that moment, okay, we ask us the question, how big should be the pilot project? And that was and we came with the 40,000 cubic meters. Then we started with a research project in Austria with 2023. And at the beginning, it was for us clear that it's not an economic case. We need some subsidies, we need supports from different kind of, from Austria, from Europe and so on. And that was the reason why we went to the ELENA. This is one subsidy from the European Investment Bank. This is for the planning of the project. The next subsidy was the EU Innovation Fund in 2024, and the third subsidy is the national funding. You see the complexity of the project, 3 fundings together to have a concept to deal with them. That's one of the major aspects to get a business case. And now we have the business case. We are currently planning the project, and the approval from our board will have it in 2026, and the planning commissioning is for 2029. And you see the long way from this first idea to the commissioning. And after the commissioning, we have all of the analyze sites, analyze years to know how efficient is the project at the end. Good. Where is the project? We use one of the location of Wien, that is Donaustadt power plant. We have already installed in Donaustadt a CHP with a capacity of 400 megawatts with some gas boilers. But the area would be a new heating area for alternative heat generation. We will have here the scale-up, but to see here, we will have here in this area deep geothermal energy. We would use large heat pumps in combination with deep geothermal energy and also in combination with the river. That means we have also here an old park based on CHP, and the new one is coming. And that is also one of the challenges of the scale-up project, because we are integrating a project in an existing system, and we know it is a development behind that. That is really not so easy to calculate and to integrate the first project, that is the scale-up in the site. Yeah, what we have done in the last year, we have we made some ground assessments. We thought about construction aspects. The floating cover was one of the biggest topics of our analysis in 2024. And what you see here is we had, for example, made mock-ups for the surface. It is a square scheme form, and we bring it to a hexagonal form because it is more stable, and the connection to the surface area is better for the surface, what we are planning for that. And that is all of the work that we have done in the last year, and also in the research project. Yeah, what we are doing currently is we are now in the planning, the detailed planning and tendering process. We don't work with the general company or contractor. Wien is, we are managing all of the interfaces, and what you see here is part of the slots or lots what we are currently planning, and we will have for each of them one contractor, and we will manage all of the total project. The major part is the civil engineering for the storage, and the storage cover is really important. The heat pump is one of the biggest parts, and also the district heating connection and electrical engineering. And these two parts is not also easy, because as I told you, we have to integrate it in the existing system, and we are knowing and also know that the system will be developed in the future. What are the summary of my slides is: one is we integrate various technical innovation in the project. One is the surface, that is the walkable surface. The second one, for such projects, we need every time an expansion tank. We integrate the expansion tank in the storage. That is really is really new. because the surface is not fixed because of the temperature changes or pressure changes. The surface will be in motion, and to have a fixed level of the surface, there is need of an expansion tank, and this is integrated in the storage. This is also one of the innovation of the project. Yeah, after the building of the project, we are going to the monitoring and to know, okay, how efficiency is the project, how high would be the CO2 impacts, and that is really also an important point to know. We began with the research, and we are now currently in the detailed planning, and after that we are going to realize the project with one team, and the team has also to be developed during the whole project. And that is also one of the major changes or major aspects of development. Yeah. Thank you.